So this year, it is estimated that companies are going to spend over $219 billion on cybersecurity. And at the same time, the cyber criminals, not to mention nation states, are going to make over $10 billion in money by attacking systems around the world. And by all indications, both these numbers are rising. Folks, what we're doing isn't working. We can't keep this pattern going. This is just not a pattern that is sustainable for the well being of IT systems around the world. So why is it what we're doing isn't working? Well, I'm going to take you back to what those of us who've been in the cyber world forever have all been taught, that the current cyber approach, that the way we're going to stop cybersecurity issues is there are threat actors who are attacking networks and devices, and from that, they're stealing and locking data and destroying it. That's and if we can stop that, if we can disrupt this chain, then we will be protected. That's what we've all been chasing for years. Here's the problem. The problem is there's almost an unlimited number of attackers, not just human attackers, but bots and other capabilities that are coming at us every minute of every day, all the time. Secondly, there's no more defined network anymore. Where we used to have our offices and we had our network devices. Now we have everything from mobile devices to the cloud to laptops, even things such as cars and cameras. Everything's everywhere. There is no defined network. There's no boundary as the term has often been used. It's gone. Everything is everywhere. And then on top of that, we're creating massive amounts of data. There's like this thing 2.5 quintillion bytes of data were created in it every day in 2020. That number has done nothing but gone up. The scale of this problem makes the current approach completely infeasible. I use this as an example. If those of you who follow, CISA puts out a list of what's known as the known exploited vulnerabilities. When they first came out with this, it was like 33 things that had to be fixed right now because they were known exploited vulnerabilities. That list is now almost 1,000 elements long, and there's new ones being added every day. We can't just keep chasing every vulnerability and every network problem. It's just physically not going to work. So, what if we became less reliant on the networks and the devices? What if we're able to actually protect the data no matter where it went? So, if the network doesn't exist, but the data still moves, we can still protect it. What if we made it so that when the attackers were successful, instead of getting millions of documents for millions of users, they got one or none? What if we were able to do that? So this concept of doing data level security is something Evolver and those of you who have read my materials over the last several years have been chasing. Done a lot of work. I've written a number of papers and spoken at conferences. We've been pursuing this for several years now, and in particularly trying to get at a granular level of securing data. Not a while back, we were introduced to a company out of the UK called Galaxy, and they have come up with a technological approach to achieving that type of file level independent security for data. And whenever I talk about this, I always get kind of the cross-eyed look to I don't quite understand what you're talking about. So what I'm going to do is show you a very simple example that I think everybody would understand, and then we'll go from there. This is an example I think all of us can relate to.
In all schools, we have teachers, and they have to work with the parents of the students. There are typical situations where the teachers have to share confidential data with parents and sometimes the students. These files are categorized as sensitive data. To achieve file-level data protection, the file must be encrypted so that only the teacher, parent and student can access it. No one else should be able to do that. Well, you can do that today with Galaxy. Let me show you how. Here, I have a K3 assessment file, which I want to share with a parent and the student. I will right-click on this file and then select the Galaxy option to Secure For. I get this dialog box, and I can select the email address of the parent and the student and secure the file for these two users only. If I right-click on this file and go to Properties, you can see the file is now secured for only the three: the teacher, the parent, and the student. This means that even if there is a ransomware attack, or if this file falls into anyone else's hands, it's no use. They cannot open it as it's secured for only three individuals. Once you have the file encrypted and secured only for the parent and teacher, you can use any mode to send the file to them. Like in this case, I'm using Dropbox. The important thing is that even if someone accessed your Dropbox, the file is not accessible, as it has Galaxy's proprietary .gxk file encryption wrapped around it. The same would be for Google Drive or any email client.
So now you understand what we talk about security at a file level. Now imagine this at scale. Imagine this for your every sensitive file across your environment, right? And by the way, as you'll notice, we're talking about doing this with the existing tools that you have, so that if you did have a breach or you did have an activity, each file is individually protected. So if you've been following the news lately, right? This is a best example. Most of the things you have today are encrypting at an application level, not at a file level. So if there is a breach, people are getting everything. In this case, no matter what tool you use, like Move It, which if you've been following the news, you're getting one file. Each file is unique, and each file is protected. So let's talk about how this is actually done and how it actually works. Okay, because if with this capability to control data at the file level and the key being controlled by the data owner, you can do all sorts of things you've never been able to do before. You can make data last for a period of time. I could say this data is good for a week and have it actually meaningless after a period of time. Data can only be seen on certain networks. I could say it can only go to these networks, and other networks you can't see it. You can even do geographic locations. And a powerful thing is you can actually automate enforcement policies such as HIPAA or privacy or GDPR, things of that sort. You can automate those functions by utilizing this functionality. So we're going to now get into kind of the value of what you've done, what we've done. The focus is on the data and who, what, and how it's managed. So that money that you're spending is less and less in chasing every single vulnerability and more about controlling where the data is and how it's managed. So the money that's being spent is less, and the money that the cyber criminals are making is less. And that's the objective of the overall concept that we have put together. But the key to making this work is that it has to be seamless for the users. I'm not talking about something complicated. It has to be affordable for all sorts of all sizes of organization and scalable to large scale.